Hello, Math Masterminds. Today we're going to be looking at writing equations in the form of y equals mx plus b. We're going to be modeling verbal, numerical, tabular, and graphical representations. Basically, what we're saying is we're going to be looking at multiple representations, multiple ways of saying the same thing, displaying the same information. In the first example, we have 15 bicycles are produced each hour at the Speedy Bike Works. Create a table, graph, and equation to show that the relationship between the number of bikes produced and the number of hours is proportional. First, we have to take a look at what information is given. Here we see that we can produce 15 bicycles in an hour. So with that information, I can create a table because in 1 hour, I produce 15 bicycles. In 2 hours, Speedy Bikes Works produces 30 bicycles. And in 3 hours, they will produce 45 bicycles, and so forth and so on. So from this information, I can easily take the information from the table to a graph. I know that at 0 hours, I haven't produced any bicycles, so therefore I will start at 0, 0. And in 1 hour, I produce 15 bicycles, 2 hours, 30 bicycles, and so forth and so on. And clearly I see that when graphed, it goes through goes through the origin, proving this is a proportional relationship. If I take a look at my table, I can also see that it's a proportional relationship. If I take the change in y over the change in x, I see that it's going to be 15, which is my constant. However, when I set up my ratios, y over x, 15 over 1, I get 15. 30 over 2, I get 15. 45 over 3, I get 15 again when simplified, which shows that's a proportional relationship because I get equivalent ratios. I can also take this information and create my equation, which will be y equals 15x, and I see I do not have a constant or a y-intercept. In my second example, Bill pays $4 an hour for parking fees and an additional charge of $10. Here I see that it's $4 an hour for parking, but I have to pay an additional charge of $10. So in 1 hour, I have to pay the $4 for parking plus the $10, which means I'm actually paying $14. In 2 hours of parking, I have to pay $8 parking fee plus that $10, which means I'm paying $18. So each time I'm going to take the $4 times the number of hours parked, in this case 3 hours, plus the 10, and it gives me $22. I can also see what's happening, so I can take that $4 times X, which represents any hour, plus 10, and that will give me my Y and my equation. When looking at the change in Y, I see that it's increasing by 4 each time. But when I set up my ratio 14 over 1, I get 14. 18 over 2, I get 9, which means I'm not getting equivalent ratios. Another indicator, this is non-proportional. In my equation, I see that plus or minus, which gives me my y-intercept, telling me it's non-proportional. When I'm ready to graph, I'm not starting at 0, 0. I'm starting at $10, which was that additional charge. Okay? And then after 1 hour, it will cost $14. After 2 hours, 18, and so forth and so on. So if I don't park a whole hour, I still have to pay that $10 additional fee. Okay, so now this shows it is not proportional because it does not go through my origin. Okay, so this kind of ties up everything we've been talking about with proportional and non-proportional relationships. If you have any questions, you can come see me in Google Meet.